We are using 5 different important equations of chapter 4 to solve different numerical problems. Out of those 5, these 2 are already used to solve 2 different numerical problems in previous classes. Today I am going to use this equation and this last one, these 2 equations to solve the numerical problem. Look at this problem. This is related with the planet Jupiter. The mass and radius of Jupiter is 1.9 into 10 to the power 27 kg and 71 into 10 to the power 6 meter respectively. Mass is 1.9 into 10 to the power 27 kg and radius is 71 into 10 to the power 6 meter. Find the acceleration due to gravity. Acceleration due to gravity symbol is small g. We are going to find out small g. What will be the weight of an object having mass? More information is given. Having mass 75 kg on that planet. Now we are going to find out the weight of a body having mass 75 kg also. Now looking at this numerical problem seems to be a little difficult, but it is not difficult problem. Look at this. I am writing the information given in this problem in mathematical form. Mass of Jupiter, this much. Mass of Jupiter is symbol is capital M, and this is equal to 1.9 into 10 to the power 27 kilogram. And another radius of Jupiter, look at this, is denoted by capital R, and it is equal to 71 into 10 to the power 6 meter. And mass of an object is also given. This object is comparatively very small, that's why I am using another symbol small m, and this is 75 kg only. And acceleration due to gravity symbol is small g. We are going to find out its acceleration due to gravity. And the last one, weight of the body, W. We are going to find out weight of the body also. This situation can be understood with the help of a diagram like this. Let's say this is Jupiter and there is a body on its surface. Its mass is 75 kg. We are going to find out acceleration due to gravity on its surface, that is g, and we are going to find out the weight of this body on its surface, it is w. And for this we have given mass of Jupiter and radius of Jupiter. Now among these equations we are using third one. Why? Because we are going to find out g, and g small g, and it is in third one. G equal to capital G capital M by R square. We have given this capital M, R is also given, this capital G is missing. If it is not given in numerical problem, we can write ourselves. Here we can write, we know what we know. Capital G is equal to 6.67 into 10 to the power minus 11 Newton meter square by kg square. Now we have small g is equal to capital G capital M by R square. Now we are writing value. Capital G is 6.67 into 10 to the power minus 11. We are not writing unit. In the process it is not necessary to write unit, but if you write it's okay. But at this time I am not writing, because at the end only I'll write this new unit of the asked quantity. 6.67 into 10 to the power minus 11 into mass of Jupiter is given 1.9 into 10 to the power 27, and radius is given. Radius is 71 into 10 to the power 6, and this is square. Now we can use calculator. 6.67 into 1.9. This is equal to 12.673. 12.673 into 10 to the power minus 11 into 10 to the power 27. In denominator look at this. This square means what? The same can be written twice. 71 into 10 to the power 6 into 71 into 10 to the power 6. 10 to the power 6. Now, this is equal to 12.673. 12.673 into 10 to the power minus 11 plus 27. If base is same, power can be added. That's why. Now, in denominator, 71 into 71. 71 into 71. This is equal to 5041. 5041 into 10 to the power 6 into 10 to the power 6. It means 10 to the power 6 plus 6, 12. This is equal to, now 12.673 divided by 5041. 12.673 divided by 5041. 5041. This is equal to 0.002539. 0.0025139. There are all other digits also. I'm not writing all the digits. This into 10 to the power 27 minus 11. How much it is? 10 to the power 16. Now, in denominator, 10 to the power 12 is left. 10 to the power 12 is left. 10 to the power 12. Now I'm writing here g, small g, or small g is equal to 0.0025. This is very small number. I want to express it into power of 10. If this decimal point is shifted to this place, then we'll have 2.5139 into, now decimal point is shifted to right hand side. How many digits it is shifted? 1, 2, 3. That's why we have to multiply it with 10 to the power minus 3. In previous class also I told you about this. Into 10 to the power 16 is previously there. Now 10 to the power 12 in denominator. We can take this 10 to the power 12 of denominator into numerator. It becomes 10 to the power minus 12. Or g is equal to 2.5139 into 10 to the power minus 3 plus 16 minus 12. Or therefore g is equal to 2.5139 into 10 to the power 16 minus 12, because 4 minus 3 equal to 1. Here this is not the final answer, that's why I'm writing again. Or therefore g is equal to, now we are multiplying this 2.5139 with 10. If it is multiplied, then it becomes 2.25.139. Instead of writing many digits, I am writing only 2 digits, 1, 4, because the third digit is more than 5. That's why I'm taking 1 from third digit to second digit after decimal point, and it is 25.14. And the unit of acceleration due to gravity is meter per second square. This way we got one answer. G is equal to 25.14 meter per second square. Now again we have to find out another physical quantity also, that is the weight. Again, weight of the body is the product of its mass in acceleration due to gravity. Mass is given 75 kilogram and acceleration due to gravity is given, not given, we found this, 25.14 meter per second square. Now multiplying these two, we'll get weight of that body. 75 into 25.14 is equal to 1885.5. Therefore W equal to 1885.5 kg meter per second square is Newton. and this is the unit of force or unit of weight. This way we can solve numerical problem related to this third equation and fifth equation. Next class we'll use this fourth equation.